Hello everybody, this is Tavo Exam Coach. Today we have a new GMAT quantitative question. The question goes like this. The letters A, D, R, O, I, and T can be used to form six-letter strings as A, D, R, O, I, T or T, D, A, R, O, Y. Using these letters, how many six-letter strings can be formed which neither begin with T nor end in A? The question divides the whole group of six-letter strings. This is a total number of strings or the universe of strings that can be put together using the six letters in groups with two intersecting characteristics. The first intersecting characteristic is beginning or not with the letter T. The second intersecting characteristic has to do with ending in A or not. This is interestingly represented with a double entry table in which one of the characteristics is to begin with the letter T and not begin with T. The other characteristic would be end in letter A and not end in A. There is here the total of elements, which represents a total number of six-letter strings that we can assemble using the six different letters. So let's represent the intersecting group that we want to identify, those letter strings that neither begin with T nor end in A. That is to say, it is this group here that doesn't have these two characteristics, neither beginning with T nor ending in letter A. And let's call, for convenience, these other intersecting groups, the counting groups, Y, W, and Z correspondingly. Let's also identify first what is the total of elements, that is to say, the total number of six-letter strings. According to the principle of multiplication, if we want to form a sequence or arrangements of six different elements, we need to pick in the first position any of the possible six letters, then in the second any of the remaining five, and thus we'll continue decreasing by one each of the number of options for the next position. And so we'll have this. Multiplying the numbers of options for the individual positions will give us the total number of six-letter strings possible, which will be 6 factorial. So let's place here this value, the total number of six-letter strings. Now, let's see that in order to identify X, considering that X plus Y plus W plus Z is the total number of strings, we want to identify the value of X. The total number of strings ending in A, which will be the sum of W plus Z, can be calculated in this way. You have these strings of letters ending in letter A, and according to the principle of multiplication, we have the 5 positions for the first 5 letters, and we can select any of the other 5 letters in the first, any of the remaining 4 in the second, and so on, always decreasing by 1 the number of options. In the 5th letter of the string, we would have just 1 option. So this product here, which yields 5 factorial, is the total number of strings ended in A. So we have that this is totally 5 factorial. Now, if we wish to calculate the total here, which is the total of strings beginning with the letter T, which is equivalent to W plus Y, this would be, according to the principle of multiplication, at the beginning we have letter T, so it's just 1 option. Then it could be any of the 5 letters available, then 4, 3, 2, and 1 corresponding. This product is also 5 factorial. So this total is 5 factorial. And then we can see that the value of W can be calculated for those strings beginning in T, having 4 intermediate letters, then ending in A. So what is the number of options for these strings? In the first position, we got just 1 option. In the last position, we also got 1 option. Then in the second position, it could be any of the 4 remaining letters. Then any of the 3 left, then 2, and then 1. So the total here, according to our principle of multiplication, would be 4 factorial. So we know this to be 4 factorial. Here we have the difference Here we have this difference. So just focusing our attention on this column here, we could see that 5 factorial minus 4 factorial plus x equals 6 factorial minus 5 factorial. So the value of x would be 6 factorial minus 2 times 5 factorial plus 4 factorial. Okay, you could see that the value of 6 factorial is the same as 6 times 5 factorial. So this difference here can be factored as 4 times 5 factorial, and this is 4 factorial. Because this is 4 times 5 times 4 factorial, then this sum could be factored as 4 factorial times 20 plus 1, or 21. But 21 multiplied by 4 factorial, which is 24, is a number ended in 4. Among the 5 answer choices, the only value ended in 4 will be 504. So D is the correct answer choice. Thank you for watching and see you on the next video.